Hello, welcome back to the video. We're in that period now between Christmas and New Year where everyone's full of cheese and doesn't even care what day it is. So, right, I've finally had a postal delivery, especially after all the strikes and stuff that's been going on. So I've got a couple of bits turned up. So yeah, let's carry on with this 60 clone. So, where we got to before was we'd epoxied down the cartridge port, so the first thing we're going to need to do is stitch that in. So let's turn this over like that, and then he says, where's his glasses gone? We had them a minute ago. There they are, they're behind me. Right then, so back with 0.7 solder. Let's just quickly stitch this in. So this is usually quite nice to solder, but for some reason it's being an arse. It doesn't, yeah, that didn't want to go. So I'm just going to quickly give it some more flux. There we go. Don't know what the hell happened there. That's what I mean. I had to give it a lot of heat for it to flow, and yeah, it's not really something you want. I'm going to put the extractor on for a minute, just while I do this. Here we go. So I hope everyone had a good Christmas. And I ate and drank far too much. I know I did. Here we go. Oh, look at that. That's flowing a lot better now. Lovely. So you can see, you just heat it up. Hold the iron on the board and the pin, and then just feed the solder into it. Superb. And just whip the soldering iron away. It's just flowed. Look at that. It doesn't quite go, just a bit more. There we go. I think some of them might have a little bit of trouble because of the hole size, but it seems to be okay so far. They all look fairly uniform. Oh, this one's taking a bit longer. Nice. Ah, that's on the ground plane, that's why. Because it's on the ground plane, the copper seems to absorb more of the heat quicker. It's usually why I have a 400 setting for boost. You can see it doesn't take long. Once you get it right, they'll look very uniform once you've done it. Again, I'm soldering at 350 degrees. It's my preference. Could go cooler, but like I said, you'll be spending more time with your iron on the component. There we go. That's it. So it only takes a few seconds and the cartridge port's completely stitched in. No problem. Now once that's done, we're going to remove the zip ties. We don't need them anymore. They've been on there for days. So I'm going to just use a ridiculously undersized pair of cutters. Where's my bloody cutters gone? There we go. Just trim through that. There we go. I'll get it that side. And come on, there we go. That's gone. So yeah, we can bin that obviously because we just cut through it. And then our cartridge is stitched in place to the board and soldered in. Lovely. Right, so let's see what else we've got now. So going back to connectors, the delivery this morning, we finally got the joystick ports through. So Phil at Retro ReFix, I ordered a couple from him, and these are pulls. So they're salvaged ones, so they weren't very expensive, and they're correct. Let's get them out of the packet. But you'll see what I mean now. These are some hideous things. So these are my ports that I've got, and I've got a shit ton of them. And these are the actual ports that are on the 64. As you can see, they're a lot deeper, and the pins compared to the holes are set back. We can see that, right? That was the problem. But anyway, we've got the right ones now, so we can just take out the screws. There we go. I'm going to put them back in once it's done anyway, so there we go. Now, because these are salvage parts, they've already got solder on the pins. I don't know if we can pick that up very well, but all we've got to really do is flux the pins at the back on the board. Nice bit of flux on there. Lovely. The hard bit is getting them to sit flush. But what we're going to do is we're going to drop them through, and then we're going to screw them down. So that way there's no ambiguity then. They're in position. The screws themselves will hold them in position. What I have noticed is the holes are slightly bigger than the screws, so there's excess play in it. So get it squared up to a position you're happy with. The pins, and then tighten up the screws, because you can actually get it out of position. So let's just nail this down a bit. And they do move when you screw them up. Be a bit careful of that. And then just tighten them up. Let me just hold it up to my face so I can see. Now what I've done here is I've made the edge of the PCB in line with the ports. Right, I don't know. Can we see this? Let's get the light over here a bit. There we go. Yeah, so it's parallel. If you run your finger down it, the board and the end of the sockets are parallel there. See what I mean? Yeah. And then what we do is stitch them in. That'll just take a second. Here we go. Because they're being held in with the screws, get a face full of solder fumes. Never good. Yeah, because they're being held in with the screws, you can just take your time and just solder straight across them, knowing it ain't moving. And these are flying really well. I don't know if this is coming out alright. There we go. Same deal as before. Iron on the pin and the board, and then just apply heat to the joint. Apply solder to the joint of the components, not the iron. That has come on well. Yeah. bit more on that one. There we go. They're both in there. Superb. Okay. So let's turn it off. So that all looks pretty cool. Now, going back to one of my earlier videos, I used one of these modulators, and this is from, I think, a guy called Matt. Anyway, it's M bar ZCZ or something on GitHub, and he makes these, and in my opinion, I think these are the best replacement modulators I've come across, and I'm going to use one on this board. So I've printed a little picture frame for it to sit in, because otherwise you're going to be touching the board with all these pins on the back, and yeah, I don't like that idea because I think it's all ground. So this will hold it above the board, but it'll also mean that the pins, the plastic bit on these pin headers here, they can sit in board. So let's just snap off 4 of those. We need 4, and typical, the next one's 5. We'll just nip one of those off, and they fly off at warp speed. So anyway, when they go through here, because of the little picture frame, you can see the plastic sits underneath, so you can put them in, stitch them in, and it all goes nicely. That's just my little thing, that is. So yeah, so we've got to get these in position now and solder them on, and that's a little bit more difficult. Again, these are pin headers, so you definitely want to flux them. These things can be a bit troublesome. I think it's something to do with the coating on them. And then on the back of the board, I'm just going to flux up there. Well, there's not a lot of gold left on the back there. So we're going to do one at a time, and we're just going to stick it through the board and try, it falls out, so you can hold it in position until you lower the board. Yeah, don't we hate pin headers. Right, so there we are. Right, I should have done this earlier, I think. The depth of the board with these components, there's enough space for it to fall out. Let's see if I can't drop something on there and just hold that in. I only want to tack one in so I can manoeuvre it by hand. There we go. So I just want to, a little bit of solder on, don't want to fully do it, and then look, that's well pissed. That's okay, because I'm going to use one finger on there just to true it up when I reheat that pin. Until it's right, which it's not. So we'll have another go at it. There we go. And it's still not right, but that's okay. There we go, that looks better. Now it's right. So I don't know if we can see this okay. Let's have a turn it around there. So yeah, what we've got is it now sticks upright properly. So we're going to do the same thing to this one, and we're going to just lay that down on the flux pen so it doesn't drop the pins through the board. A cack-handed way of doing it, Lee. Now right, one more. There we go. And that's definitely pissed. So let's just true that up. And there we go, they're both in line. So that's excellent. So before we go any further, we're going to fully stitch these down. There we go. Just going to quickly solder these on. When you do stitch them on, don't start with the pin you've just done, otherwise they'll drop out. So go to the pins around them first. And the last pin you want to do is the one that you tacked them in with. There we go. They look hunky-dory. Now for this side, all we got to do is flux up the holes. Like that. And drop that over the holes. There we go, just like that. It is that simple. Just push it all the way down. Make sure it's sitting how you want it, and it is absolutely square first time, which has surprised me. Right, stitch it in. Doesn't matter that the pins are longer this side, doesn't matter at all. There we go. This might take a few seconds extra just to get the heat transfer onto the pin before adding the solder. In this case, I don't know, you won't be able to see it, but I'm actually contacting the pin next to it, and it's now bridged, that one. It's not the end of the world. All you do is you heat it up. Let's see if you can see this. Just heat it up, and then draw it away quickly. So you push it in and just pull the soldering iron back, and that clears the bridge properly. And that modulator replacement is in. Lovely. Right. Next up, what have we got now? Let's start with the 12 volts. Okay, so 12 volt regulator. I don't think that's going to be working too hard in this machine anyway, but okay, so we've got a 12 volt regulator and we want it to sit through the hole. Now what we need to do here is bend the pins so that it all goes through nicely. So all we do is we take our point here and then just bend all three 90 degrees, drop it through, and that is absolutely spot on. Unfortunately that it won't be spot on by the time I solder it because something's going to move. So again, we're going to turn it over. Just going to drop it out of the way for a second. We're going to flux that bad boy up. I'll flux that one while we're at it. And then we're going to put this in like so. Now, even though there's 3 pins there, something is going to not be happy. So we're going to put a bolt through it. I hope this bolt fits. Yeah, just to hold it in place. There we go. And get through that. There we go. Like that. And I'm just going to bend one of the pins forward just to try and, there we go, and it has still dropped, but that's no problem. We're in the right ballpark now, so let's just add a little drop of solder to that and pull it up. There we go. And that's done the job. So just a bolt with a 3mm bolt. It's quite handy for manoeuvring parts, and it's in the right position. So now I can just stitch in the holes properly. Oh, bloody hell. That regulator's in, and then we just trim off the excess feet because they will be higher. Just like that. Just like that. Job's a good one. Right, so that's a 12 volt regulator in. The 5 volt is a little more involved because we've got a copper heatsink to go on there. Now, this came from Retro. Cheers, Phil. Yeah, I didn't have the right regulator. They were out of stock at the time, so it calls for a 7805 CT, which is a 1 amp regulator. I've got some cheap Chinese 7805 CVs, and I'm going to use one of those. And the difference is it doesn't go down to -40. It goes to 0 degrees to function, and it can deliver 1.5 amps rather than the 1 amp that it calls for. So realistically, I don't see it making a big amount of difference, but there's a bolt to go through this, so we need to offer it up first to find out where we're going to bend it, and it looks like we need to bend it just past those shoulder bits on the pin there, and bend that 90 degrees. That's a clean bend. We'll drop that through there. I've just fluxed it a minute ago, so that's okay, and that all lines up perfectly. So now what I'm going to do is, I've got some old silver paste for heatsink compound. I'm just going to put a little tiny smidge on this heatsink. Now, you don't have to do this, and this is really overkill for what I'm about to do, but I'm just going to put a little tiny bit. That is a little bit. And I mean, it needs an ultra small bit. So to give you an idea, that's how much I've put on, which is bugger all, as we can see there, because the heatsink is gonna when you clamp it down, it's gonna spread it out, and you do not want silver compound going everywhere. But anyway, you don't have to do that. I've just done that. So let's just take this bolt. There we go. And we're going to bolt it down before we solder it. Offer that bolt up. Come on, right through. Got a mild bit of magnetism on this bloody driver. Let's pull it out of the way. Come on, get through there, you pig. Jesus Christ. Right. Let's drop it through there with the bloody pliers. That's it. Right. So let's just go to the other side of the board and put that on. Right, so the camera shut down again. It's not as cold, but it is cold, so yeah, need that, don't we? Yeah, so I've just found out, I don't know if I've recorded this in the last segment, but the power connectors I've got, 2 of them, both of them don't fit. This has got some kind of strange, shallower type profile. That's fucking bollocks. So, yeah, I'll have to do something about that. Anyway, we'll continue here. I've got a, for this Q1 transistor, I've got a tip 29 transistor here. I'm just going to offer this up. While we're at this, you see, might as well get as much done as we can today. And there we go. It's just a about a mil or two past the shoulder, and bend. Look at that, lovely. So I'm going to use the bolt trick. There we go. And the bolt can definitely hold it. And I'll bend one of the pins slightly just to hold it in position there. Now it'll drop and it'll move, but that's not really a problem. Right, so what I'm going to do is tack this in. Right, now I'm going to heat it up and then manoeuvre it with a bolt. There we go. Let's just have a look where we're at. Beautiful. Right, now just solder these other two pins. There we go. Cut off flux at the face. Just trim them off. There we go. Make sure the pins drop off the board. Sometimes they don't because they're covered in flux. Okay. So the next thing we're going to look at, we've got all these components on now. We haven't got a crystal because obviously I'm using a Commodore, as I said earlier. We don't have to worry about the clock chip or the jumper yet. So I'm still waiting for a Zener diode to turn up in the post. Let's go back to what happened with this on the last video. Now this is a bridge rectifier. The silk screen puts the cutout down this corner. Now looking at the data sheet, this particular one, the positive is at the notch, so that's the important bit. Now the positive supply means that you're going to have DC coming out of it, so I'm just going to bell where that's going. Now logically you're going to rectify 9 volts and you're going to go to the middle, or you're going to go to the supply of one of the voltage regulators. So let's just, that's it. So if we go, let's take the positive pin, it should go right, it goes to pin 1 of the 5-volt regulator. So I shall just quickly pull that up. He says I'm at the Wi-Fi zone, so it'll take a few seconds. But my point is that we're going to have to go against the silk screen and line up plus to plus. That's going to be the way we're going to do this. And that'll fit all the way through there. Lovely. Quite big pins, so I'm just going to bend them outwards slightly. That should hold it in position. So yeah, after it's been rectified, it stands to reason that it's going to have to be regulated. So we'll just check to see what pin 1 is. There we go. And on the phone it says pin 1 is input. There you go. So that looks correct. And that's exactly what we want. Now, pin 1 on the regulator, as long as we make sure that is not ground, we are laughing. So, okay. There we go. Now pin 1 is going to be this bottommost pin here, one closest to this edge of the board. So we're going to take that pin and just pick up on some ground points. That's not. The centre pin's ground, and that's correct. So we're happy days. We're ready to drop this voltage regulator in position. Let's just stitch in one leg. We'll boost up the soldering iron. There we go. And we're just going to tack it. There we go. Get around the back of the board. Just apply a little bit of pressure. Push it upwards. That should be flush. And it is. Lovely. Let's just stitch that in. There we go. Big amount of solder here. Big pins. Come on. Make sure it fills the entire pad. There we go. Lovely. Right, so we've got to cut these legs off. These are quite big. They're quite soft. So let's just do one at a time. And that is the voltage regulator on. The board is almost complete now. Yeah, I'm not entirely sure what we're going to do about these sockets yet, because although one of them will fit, it's not right at all. It's definitely not right. I've probably got a pull somewhere, but I don't want to use one. I'll have to have a look and see what I can find. Yeah, so shut that down. Right, so the next bit we've got to put on are some of the connectors. Now there's a 3-pin connector which is for the LED. So we just take a bit of pin header, snap off 3. That's ready. For the, there we go, and that one there, that takes that many. There we go. So for the keyboard connector, we need to polarize it. So we pull the second pin out. He says, come and grab hold of it and just pull it out of there. So it looks like that. See that okay? So that's easy enough done. All we've got to do then is just flux these up. Lovely. Flux up these, no problem. And then the back of the board. There we go, it's these 3 here. Connect to here. I'm going to do the same thing that I did before. I'm going to off up the pins for it, tack it in place with 1 pin, maneuver it to how I want it to be, and it drops out, and then stitch it in properly. So just use something there just to hold that. Lovely. There we go. Okay, let's just do one near the centre. It's done. I don't believe it. Actually pretty bloody good. Okay. So to stop it moving, we can do one at each end. Check it again. Lovely. Okay. Just those down. There we go. So that's in. Right, that's the keyboard connector in. Now for the power LED, I'm just going to try and do that again. Gets a bit more awkward when you've only got a very small bit of pin header. It's even more awkward though is doing this stuff on camera. Right, there we go. I'm just going to tack one in like that, and we know that's well and truly fucked. So let's just manoeuvre it while we heat up the middle pin. Spot on. Right, stitching it in. Right, that's the power LED. Now I have got the choke that goes up at L1 position, and I bought a couple of Chinese ones. They're not strictly needed, yeah, so what they are these. I'm going to fit one, but not right now because that's going to be the highest point on the board and I don't want to scuff the coil. Yeah, so I'm going to leave that as it is, but you could, if you're running it from a nice supply, just strap across them. The whole point of it is it uses the same interference on the opposite coil to cancel each other out. That's why it's called a common mode choke. Yeah, so it just tries to cut down some crap coming into the 64. I don't think that's so much of a problem today because no one's using RF and we've all got some nice replacement power supplies. See the first video. But yeah, the bigger problem is going to be this epoxy connector here, and I didn't expect that. So like I said, I bought two different ones confident that I'm going to smash this, and neither of them fit. Well, these ones fit. This come from China, but it hangs over the end, and that's really weird. So the whole thing needs to be shorter. I bought 5 of them. Well, to wait ages as well. What's this connector I've got here? I don't think this is going to be the one. No, 1, 2, 3, 4, 5, 6, 7, 8 pins. Wondering now whether I can just remove the centre pin. Does it actually fit though? No, this one hangs over as well. So this is a special connector. See, I could just trim off the 8th pin, but this is the same depth as the other one. So these 64 power connectors, they're shallow. Who would have known? They're only shallow by about 3mm. What a fucking pain in the arse that is. Fuckers. Anyway, yeah. So I'll pick this up at the next point and we'll continue that. Oh, for the magic of editing. Right, so here we are back again. The board is almost complete now. It's, yeah, it's pretty good. All we've got is 2 components left to put on. Sorry, 2 missing components, and 2 that I've already got. So I was missing the 2.7 volt Xenon diode there, the axial ceramic over here, and I've got to put on the choke and the power connector. That is it, and this is done. So they turned up this morning. So as you can see, I'll get a little packet turned up from eBay. I'm not using the 1N series, I'm using the BZX 55Z Xenon. They're both rated at 500 milliwatt, I believe. So they should be fine. It should act the same way. I'm not paying bloody 6 or 7 quid for one diode for a 1N one. So what size have we got here? And yep, we're at that size there on the former. So just hold it central, bend the legs down, look at that, superb. And we'll just drop that through the board like that. That's exactly what we need. Prop that board up there. No, that's right over. Okay. As you can see, I've got very little gold left on the back of this board now. And the soldering iron's already hot. Let's just drop this in position. Make sure it's flat. Yep. This leg could do with coming up a bit. Now what I'm going to do with this side is, because this leg could do with coming up a bit, I'm just going to grab hold of the leg, heat it and lift it at the same time just to make sure it's fully up. There we go. Solder cool. Let's have a look. Ah, spot on. Okay, so just fucking trim them off. Ta-da. One done. Now it's just the axial. Got some nice ones here. I did get one from Retro ReFix. I could use one of those. They're both 50 volt rated. The guy got back to me yesterday, so but I've got these in front of me now, so that'll do. Yeah. Now this, let's make sure that's the same, and it is not. So this is a bit bigger, the whole distance between this one. Bit strange, but there you go. Like I said before, it's usually the same, but not always. So just form that. Drop that in there. Boom. There we go. Just knit them together like that. So just like before, I'm going to do one side. And just like that. Boom. Then I'm just going to lift it, make sure it's pulled flush. Oh, you heard it move there. Just sanity check and make sure, yep, nothing funky's happened. I'm going to do the same on this side. There we go. Right, we're going to heat this up and pull it at the same time. Yep, nice. And trim it off. There we go. Let's have a look. Oh, perfect. Right, so what have we got left? Now, we've got a bit of a problem with this fucking epoxy power connector. And yeah, as I was saying before, the ones I've got are too deep. So, although that's the wrong one, although these ones here, I've got a pack of 5. Although it will technically fit in the holes, as we can see, it sticks over the end of the board. So it's about 3mm too deep. But I'm still going to solder it on. Retro does the right ones, and I will get one. But for now, I'm just going to, for the purposes of getting this board running, I'm going to use this one. I'll desolder it later. I've got a proper desolder station, so that's no problem. So I'm just going to tack these in. I didn't use flux, and look at that, it's not all that great, is it? That's what happens when you don't use flux. You'll get it nice and hot. Come on. The reason I'm not giving a fuck about this is because it's coming off again. So it's only got to make temporary, it's only going to be a temporary power connector. There we go. Now for the sake of that, I wonder, it's probably not clever, but I'm going to do it anyway. Let's, so I can't bridge that. Fucking A. Bodgerama, yeah. So I've just tacked these to the edge there. So all the pins are connected. Nothing's joined. It's hard to see in the light, but what you notice is there's lots of spitter spatter on the back where the hot flux it spatters and goes everywhere. So the main problem here is we've got to clean up the board. I use no clean solder, but you still really need to clean it up. Now I do generally keep amongst this shit a brush here. Oh, it's over here, I've moved it. Right. So you can get these for a couple of quid, and all it is isopropyl alcohol, and just give it the big one. So yeah, give it plenty. Don't go cheap on it, and then just give it some of this. You want to remove the blobs of flux on the board, so don't be afraid to give it a bit of a scrub. Obviously don't get your fingers near it because it'll rip them to pieces if you catch your knuckles on it. So yeah, let's just give it the big one. Now, a lot of people use an ultrasonic. It's fine if you've got an ultrasonic bath big enough. I, however, do not. Mine won't fit the board in it. So just give it a nice good going over anywhere where you've soldered. Stuff stinks. Don't use it if you're a smoker. Right. It will evaporate, but it'll also leave some of the residue on the board, so it might take a couple of attempts before you can get it all off. Once you've done that, you can try using some tissue or something just to pitter-patter it down. To be honest, yeah, it's going to start tearing and leaving bits of tissue everywhere. Some people use cotton buds. Yeah, that's useless. It's only good for areas where you haven't been soldering really. See, it leaves these little bits of tissue behind you've got to remove afterwards. We don't have to, but who wants bits of fucking tissue everywhere? There we go. Let's just clean it up. Like I said, that might take a couple of attempts because the flux you're actually trying to remove, you're distributing right across the board. So it might look a bit weird after you've done it. Now, that's an interesting thing there. I don't know if you can see this, but underneath that solder connector there's an errant bit of solder. See that there? When you get something like that, I recommend you just use a screwdriver and just dislodge it, and suddenly it'll move. See? You want to give the board a good visual inspection when you've done it, because any small pieces of solder like that can bridge stuff, create a bridge between pins, and that's what you don't want. So once it's all dry and everything else, just give it a good look over. That's going to take a little while to dry. Right, so anyway, this connector's on. The last thing we're going to put on is one of these chokes. Like I said before, you could just bridge it. That's no problem. Now we can just strap across that. Before we fucking nail that down, let's just make sure this is right. Because we don't want to be crossing that coil and getting it wrong. There we go. Right. Well, they're two separate circuits, as you would expect. And how is this looking to go? Across like that. So it's looking to go horizontally. Right, so that's one lot of power there. Let's bridge in that one to that one. Yep. Okay. The back of the board's got very sticky now because of the isopropyl and the mix of the rosin flux. I have actually got a cartridge shield to add, but I'll add that one later after I get a proper bloody power socket. I'll do that then as the last job. So there we go. Let's just pop that on there like so. And then we're going to stitch this in. God. Fumes everywhere. Come on. In you go. Bing. And last one. Right, so let's just remove these legs and get them a crap pot. There we go. That's the last leg. Excellent. So that's all soldered. Now the back of the board is quite tacky now. So what we're going to do is we're going to give it more. Shield camera from it. Again, we're just going to do a general once over, nothing too funky. I fully expect to do this 2 or 3 times. That's all quite normal. Okay, now that that's done, I'm going to put this out of the way, and I'm just going to spray it and leave it stood up so some of it can run off. It'll evaporate as soon as it hits the floor anyway. It'll take some of that residue off. Yeah, there you go. It's running off like a bloody... Yeah. God, that really bloody stinks. Okay, so that is done. I'm going to put that down there on the floor just to drain, as it were. Okay, that board is fully assembled. Right, let's talk ROMs. So, this ROM here is one that I got off eBay. The blue board bit was called just coincidence. So you can actually select up to 16 different ROMs. It already comes pre-flashed. I'm not sure all of them are any good because this type of board uses a special ROM format, like I said before. And this is in that format, and this format was also used in the 1541. So it's got a couple of 1541 ROMs on there. Not that that's a big issue. Yeah, for what we're going to do, this is going to be our kernel. So it costs £12.50 and it's turned up like this. Nice, that's ready just to plug in and use. Now, as I said before, I'm going to use this open board. I've had it assembled a little while, and this is from as we can see here, I don't know if you can read this. Let's just get this over here a second. Yeah, GitHub Sucopera Open 2327 ROM adapter, and basically this allows you to use a standard JEDEC format ROM, EEPROM, in place of the smaller format that it uses in the 64, and I'm going to use this for basic. So this particular adapter can use a 27C 128, which is 16K, 256, which is 32K, or a 512, which is, you guessed it, 64K, which is, I think, what this one is that? Yeah, this one's a 512. Yeah, so you can then use the 3 lines to select which ROM you want to use. So yeah, I'm going to program up a 16K ROM with 2 copies of the 8K basic, top and bottom, and then just put that in here and use it. The reason is you can't really get an 8K ROM in that type of JEDEC format that fits nicely without more pissing around. So yeah, that's what I'm going to do. It's simple. I've got plenty of 16K ROMs around, and that's how we're going to do that. So yeah, so all I've got to do is select the lines that I'm going to pull high. So I'm going to desolder these in a moment and put new self-mounted surface mount resistors on, and that will pull certain lines high. And the reason for that is in order to tell which part of the chip you want to access, is going to be either high or low. And what I'll do is I'll add in a bit to the video just to give a quick ROM primer as to how things are accessed in the 64. Okay, so here we are back again, and I've got, well, let's face it, it's shit drawing time again. So here we've got just a really fucked up lash up of some of the chips in the 64 and how they communicate. So we can see that we've got red, black and blue lines here. Now we're going to say that the blue is the address bus, the red is the data bus, and the black are the chip enables from the PLA. And this, I know I'm absolutely bastardizing some electrical concepts here, but for simplicity's sake, the ROMs in a 64 they work like this. It says when you power up a 64, it's a 64K RAM system, but it's actually 16 address lines giving you the addressing capability of 64K. So what that means is, if you don't know your binary, you got 16 lines and that gives you 2 to the 16th or 65,535 addresses, assuming that you're starting from 0. It's 36 if you're starting from 1, but so it's actually 64k, and we all know a k is 1024. Times that by 64 and that's the number you get. So what this means is that in order to address ROMs, you toggle each bit line to read it. Now I know that might sound like a strange concept, but with this type of logic it is either on or off because it's digital. So a 0 means it's off, and if it's high, let's say it's 5 volts, right? That is not the case, but 5 volts signifies an on. Briefly, the difference between TTL and CMOS logic is the point at which it turns on. I think from the top of my head, TTL logic turns on about 2.7 volts. Anything below that is off, anything above that is on. CMOS has a higher turn on threshold, I believe. I'm doing this from memory, so don't shoot me down for that. But that's the difference between TTL and CMOS. But anyway, there's a threshold point that anything above it is on and anything below it is off. So we're going to say 5 volts is on and 0 volts is off, which it would be, but in the 64 it doesn't always get to 5 volts. Right, so yeah, I digress for a second. Going back, we've got 16 address lines, which gives us every possible number, every possible binary combination from 0 to 65,535. And what that does is it works like it puts a number on the bus and then it says which chip can access the bus, if that makes any sense. So all of the chips at the same time, the address bus has got one value on it because it's 16 lines that go right across the PCB. So whatever you write to that address, that's what you've got. And then you say which chip can access it. Now you've got 8 data lines, that's why it's called an 8-bit system. You've got 8 data lines coming out, and yeah, whatever the chip does, it then presents data on the data lines. Or it can read from the data lines. It's bidirectional. So in the case of the CIAs, I believe, they can read and write the data lines. Some of them use the joystick port, some of them use the keyboard port, some of it uses a serial port, yada yada yada. But anyway, so the way that the ROMs work is you've got these 16 data lines, yeah, and that means that the maximum size chip, without any funky sort of bank switching or anything like that, is a 512 chip, which is 512 bits or 64k. Now, what we're going to talk about is the basic ROM first. So the basic ROM in the 64 that we're building is 8k, right? So that means that if you've got, let's go 7, 6, 5, 4, 3, 2, 1, 0. Now, an 8-bit number can represent anything up to 256 or 255 if you start from 0, yeah? But we need 8k, so that basically means that we have to go past this point of 8 bits, and you go 8, 9, 10, 11, 12, 13, 14, 15, 16. This will be clear in a second, right? So this is 8 bits, and you also got this as 8 bits. Now coincidentally, if you 8 bits is 255, if you take, or 256, if you take 256 times 256, you get that number there. Yeah, how about that for a fact? Right, so anyway, so 8 bits gives you a number of up to 256. I keep swapping between the convention of 255 and 256. I always count from 0 with computers, so let's say 255. But it's 256 unique numbers, because 0 is a number. Now each bit above that doubles it. So if you've got 9 bits, starting from 0, remember, 0 to 8, that gives you 512. If you go 10 bits, you get 1k. 11 bits, 2k. And 12 bits, you guessed it, 4096, 4k. 13 bits gives you 8k. So what you have is your chip like this, your ROM, and you've got address lines going into it. Now let's say that this is a 16k chip. You will actually have 14 address lines, the same as the VIC, and that's why the VIC can only access 16k, by the way, because it's only got 14 address lines. If it had 16, it could see the entire thing, but it has to bank switch between 4 banks. Why they did that, I don't know, but there you go. So your ROM here is made up of one 16k block. Yeah. Now, in order to access this in 2 pages, you've only got to toggle the uppermost line, because what you'll have is 2 8k blocks and address line 13. If it's high, then it will do that, so if it's high, and if it's low, then it will read the bottom 8k block. So you can literally have 2 different ROMs in there and literally read whichever 8k ROM you need just by toggling one line. And that's also how you can have a kernel with a split Jiffy and standard. So if you've got 2 8k kernels, all you do is you break out your A13 pin, and you can either make it high or low, and bang, you can switch between Jiffy and standard kernel. And that's how it works. It's really that simple. So what we're going to do is we're going to use this ROM adapter, and I'm going to join 2 lots of the same 8k basic image together, and then flash a 16k chip. It doesn't matter then which bloody bank it is, A13, high or low, because I'm going to be reading it. But in the case of what we're doing, we're pulling A13 high, and we're doing that with a 10k resistor. So what we're saying is, on that board, there's 3 spaces for resistors on the back. And let's have a look, I've got it next to me. Right, here we go. So I don't know if we can see this very well, but let's have a look. I've soldered on 3 10k resistors in there. Yeah. And they are joined to the VCC or power. So they're joined to the 5-volt supply. Now what that means is I'm going to be dumping the supply into A13, but we don't want to dump everything in there. We want to restrict the amount of current, because it's only a ROM, it only needs to hold it high. So what we're going to do is we use this 10k resistor, and that basically means that if you go back to Ohm's law, you've got current equals voltage divided by resistance. Yeah? Or in this case, current equals 5 volts divided by 10,000. Now the reason for that is they're SI units, but it's just how it works. If you want to know more about that, just Google SI units, and yeah, it won't take you long to figure that out. So 5 divided by 10,000 gives us 0.1235, I believe. Now this is right, so that's 1 milliamp, so that's half a milliamp. Da-da, da-da-da-da. And that's that's the amount of power we're going to use to hold that pin high. And that's the reason for that resistor, because otherwise it would just draw whatever it could pull. Now that could end up being several milliamps or whatever. It probably isn't a problem, but all you're going to do is end up converting to heat, because you're not doing what you need to do to keep the pin high. You're using the maximum the pin can take, and they're two different things. And that's really how this ROM situation works. Now, just touching on the kernel ROM, that's a 64K. So basically what you end up with there, this is brilliant. Look at that. Definitely shit drawing time. 1, 2, 3, 4, 5, 6, 7, 8. Now I've started from 1 here for a reason, right? So anyway, what this will mean is that you've got A15 will toggle, let's see, the top and bottom 32K. So if you split your ROM into 2 again, then the top 32K and the bottom 32K will be toggled by A15. When you want to split it into 16K chunks, that'll be A14, and into 8K chunks it'll be A13. So with a combination of A13, 14 and 15, you can select any one of these 8 banks in binary. I'm not going to go into binary now. If you want to look that up, just hit Google binary. Yeah, I mean, that's fucking simple stuff. So, but that's how these things work, and that's why you use a current limiting resistor as well. So now we know that. Yeah, we'll populate the board. Well, no, we're not going to populate the board yet. What we're going to do is we're going to power that fucker up with nothing in it, and just make sure our voltages are not noodle doodle. All right. Right. So here we go. We've got the scope, the multimeter on. Don't know if you can see this all right, or whether the, I don't know if you can. Yeah, that's better. You can see that now. Right, so I've got the power supply I made in episode 1, and yeah, it's plugged in here. Yeah, all we're going to do now is just give it some power. I've populated the fuse socket, and all we're looking for is a decent 5 volt and 12 volt line, although I don't think we're going to be using much to do with the 12 volts. Yeah, so anyway, we're going to just check the voltages. So let's turn that on. Nothing's going to cook because we've got fuck all in it. Now what we're going to do is we're going to go to the ROMs. So bottom left is your ground, top right is your power, and look what we got there, 5.17 volts. Kernel ROM 5.17, basic ROM 5.17. Now the VIC is a bit of a different beastie, and that's because it's voltage selectable from the modulator. But let's just check that. 4.97 volts on the VIC. Well, fucking happy days, isn't it? What we got here? No, let's put, oh, the 8701's got a different pin out. Let's have a look at down here. 5.17 volts. Well, this all looks pretty good. So let's pick a ground point on the board, anywhere that's ground. So it'll be here, and this is our 12 volt regulator. So the output will be the right hand side pin, 11.99 volts. Fucking A, spot on. So at least we know that our bridge rectifier isn't blowing the arsehole out of anything. So yeah, voltage wise we look ready to rock and roll. We know that our choke is in the right position, and yeah, we're ready to populate this fucking board. Happy days. I shall populate it and be back. Okay, so we've got the board fully populated now, and we can see that I've got the multi-kernel ROM in here. Next to it I've got the chip I flashed, and I've put 2 8K basic ROMs in, so it works. no problem. And all I've done is I used the copy/B command from a DOS command line and concatenated 2 sets of the same basic ROM, so we know we're good there. And that's it, it's sitting in the adapter that I showed earlier. So I've just printed a nice little label and stuck it on the top. So yeah, we've got a 8500 CPU, a character ROM that's a pull, a couple of CIA chips from eBay. This is one of those $3 PLA things. I boshed up a couple of them, so yeah, I quite like these. They work really well. And we got a Swin SID. I have got better things, but I didn't want to blow the arsehole out of something nice, you know, like an arm SID or something like that. So I made a batch of these up anyway. Right, so yeah, it's all plugged in, all ready to go. The good thing about this multi-ROM is if you switch it to number 2, it's got a dead test on it. So yeah, what I'm going to do is I'm going to set this up in a minute. So let's just have a quick power on first. There we go, look at that. How crunchy is that video? Damn, that looks damn good. Let's see if I can't get a nice zoom in on that. Look at that, how crunchy is that? It's going for a Retro 2X Pro, but that looks damn good. And that's the Kawari Mini here. So I've got no clock chip installed, no crystal oscillator, just the Kawari. And yeah, look at that. It's all powered up, ready to rock and roll. So what we're going to do is I'm going to get a tripod set up, and then we'll give this thing a beasting. Okay, so here we are on a tripod. The first thing we notice is how much current we're pulling. 610 milliamps. That's a whole lot less than the normal 64 pulls, and that's got to be down to the Kawari and using a couple of EPROMs rather than mask ROMs, which will probably use a bit less, as these are modern replacements. Of course, we're going to use a hell of a lot less with the SID because, well, it's just an Atmel part, so that's going to sip power, as it were. And yeah, so here we got the top off the junker. So let's just power this off. I'll just drop on the power LED. Make sure this is all pucker. There we go. Keyboard port is obviously keyed. Yeah. Now, I bought the Kawari and I haven't actually tested it until right now, so this is all pretty good. So let's have a look. We've got power light. And yeah, oh bollocks. Right, so first things first, we're still in dead test mode, so let's just whop that back to 0 and burn up normally. Look at that. Damn, that looks so crunchy. That is absolutely superb. I haven't even played with the pots on top here yet, so it's literally as I built it. I'm sure that with a few tweaks of this I can actually make this absolutely perfect. Yeah, so the Luma Chrome on top here, you could, oh look at that. Well, you're probably not going to be able to see that, but you can actually remove the bars altogether. What little bars there actually was. Look at that. Superb. So when it was started up, the first time I did, before I started filming, I did a test turn on and nothing happened. And that's down to the Kawari. I had the modulator set to 5 volts instead of 12. And the Kawari just said bollocks and just fucked all the way off. So yeah, I set it to 12 volts, bink, up it come. No problem. But that looks brilliant. So keyboard works. Look at that. Lovely. Right. So let's give this a testing. So if we turn that off and drop in our trusty Kung Fu flash, please insert. Oh, you fucking, what have I done? I've ejected it as I pushed it in. Tit. Right. Look at that. Last game. How crunchy is that picture? That's just superb. There is not much in that, and my HDMI enabled replacement. I don't know. There's a board you can get that goes underneath your VIC to give you component output. And I've got one of those in one of my other 64s, and that is absolutely spot on. And there's not much in the difference with this. This Kawari is absolutely fucking superb. Now, yeah, I know the sound's going. It's a Swin Sid, so it's going to sound like a fart in a tub at some point. But to test what we're doing, that's not bad at all. Not bad at all. So I've just got one load 64 version 4. So let's yeah, let's find some other shit. I know you need a joystick to start that up. Right, so if we just pick a game, a lot of these don't even bloody recognise. Yeah, look at that. Look at that. That video is superb. I'm truly amazed at that. Oh. Okay. Nice. Brilliant. So it looks like we're, you know, everything seems to be working really well. Nothing wrong with that. Nothing in the slightest. Ah, what a tune! Yeah, you know it. Right, well. That is absolutely brilliant. So what I'm going to do is I'm just going to turn that off, pop this fucking Swin out, and stick in. This is what I built the other week. This is a Sid kick. Let's just give it some of this. Look at that. Tune. Nice. That's knocked up the current draw a bit. 790 milliamps. In a normal 64, it's at 950 or 920, something like that. But that's absolutely brilliant. What else we got here? Da, 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 da. Yes, Bill, what the fuck is that? Complete with speech. Nice. These SID kicks work really well. But it's a complete Frankenstein's monster. There's loads of stuff in there that's not even original. So all in all, you know, realistically, if all your stuff's ready to go and you've got everything, you're talking probably about 5 hours to build one. So if you set yourself a good afternoon, or you know, or even a Sunday or something, you can do it. Now this Kawari, because I didn't have to install that, I can actually switch this, but there's no dot clock at the cartridge, or there's no clock at the cartridge port, because this takes over internally the clock generation. It does get a little bit warm though. So yeah, so what I will have to do is run a separate wire to the cartridge, pin 6. Cheers Steve, he put me onto that one. Yeah, Steve at Retro ReFix, check that out. Yeah, so I'm going to have to make that mod as well. I've also got the cartridge port cover to go on, and I'm going to, I've got it from Retrolian, and I'm going to give it a rub down and spray with cold galv, and then that'll all look nice and silver, and then I'll pop that on the board and then solder it in place. Yeah. But this here is going to be the basis of an upcoming video using this board. So yeah, it'll only be a couple of weeks and I'll put that out, and that'll be a little bit of an eye-opener. So there it is, a 60clone 466, the easiest one to build. Watch out for that dodgy power connector, that's a short one. Retrolium has them in stock. I am going to order one next week after Christmas and get that across, get all this put back together, and yeah, it's then ready to rock and roll. But for now, it all just, it looks good, sounds good, it's all just running really well. Look at that. What a great game. Superb. The only thing I haven't tried yet is the Easy Flash cartridge. Now that could very well cause a few problems, so let's just turn this off. God, that is so crunchy. Alright, I've got an Easy Flash here. Shit everywhere. Let's just pop this in. Right, okay. Look at that. Easy Flash has started. Okay, I've got a couple of things on here. First of all, let's see if we can overwrite with the soft kernel. So let's just see if we can get a jiffy up. Well, fucking hell, look at that. That works. Right, I can't get to the reset. Let's just flip power on that. Got a nice crunchy new power switch. Okay, right. It's working. It's absolutely working. Wow, well. Boom, 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 boom. That one. Here we go. That does look so good. I just drop that loomer a bit actually. That's brilliant. Alright, so this is a big cart, so it uses memory banking. Ah, look, it's in. No issue. Brilliant. Well, with all that said, this is yeah, that's the end of this video. So thank you for watching. I hope you all had a good Christmas and you're getting ready for the new year. And check out 8-Bit Retro ReFix. See you soon.